Okay, this lesson is on adding and subtracting rational expressions. Hey, adding subtracting can sometimes be probably the more difficult lessons of this unit, and the reason is the way that you add and subtract fractions in general. So to review how you add and subtract fractions, let's go back to, let's say, what, third grade, fourth grade, fifth grade? I don't remember where you learn how to add fractions, but what did you need to do? Because right now, 3/4 cannot be added to 5/12. Something has to happen first. There has to be a common denominator. So 12 seems like 4 can go into 12, so what I would need to do is maybe multiply the left side here by 3 over 3. Maybe that'll work, because 3 times 3 is 9, and then 3 times 4 is 12. And then this over here. Hey, now look, they have a common denominator, so I could add them together now. And when you were adding fractions, you just focused on the numerators. The denominator just always stayed the same, and 9 plus 5 is 14. And then, once you were done combining the two numerators, you're like, hey, wait a minute, I could even go further and simplify this. 14 over 12 reduces to 7 over 6. And that was your answer. It turns out that adding, subtracting rational functions works exactly the same way. But the same thing that causes problems when adding regular fractions and adding rational fractions is the fact that students just have a hard time figuring out and doing the common denominator properly. Let's look at a few problems where the denominators are already the same. So this is the case here in number 1. Both denominators are already the same. So I don't need to worry about figuring out a common denominator. The denominator will just stay the same, like it always does, and I simply add the numerator. The problem here is that 2x and 5 don't actually combine. They don't actually add. So we just write them separately. It's just, fix that, 2x plus 5. That's it. You look and see if you can reduce anything, but since there isn't any multiplication since there is no multiplication going on, you cannot reduce anything. You will find out that you can only reduce or cancel or simplify things if there is a common factor. And by factor I mean there's something common that's being multiplied. You'll see in a second. But for now, that's the answer. Let's look at another one. Once again, we have common denominator already. So the denominator will stay the same. In this case, we'll subtract the numerator. Now, just like the previous problem, x squared and 9 don't actually subtract. They can't. They're not like terms. So we just simply write them as separate. X squared minus 9. Finally, we look and see if maybe this can be simplified. Now, what some kids may do is go, oh, this is done. I'm done. I don't need to do anything. But what you guys are going to look for is, hey, wait a minute. On the top, that's a difference of squares. I can factor this. I can factor the top. X squared minus 9 factors to x plus 3 and x minus 3. Okay, well, now you look for any common factors. Now that I have multiplication going on, this is being multiplied to that, I can cancel any common factors on the top or the bottom. And you notice the x minus 3 on top will actually cancel with the x minus 3 on the bottom, leaving you with a final answer of just x plus 3. Now those are the easy ones. Let's look at some ones where the denominators are not the same. So the analogy I always use on how do you figure out what's the common denominator, I relate it to children. Because I have 2 small children, what I've noticed is that my oldest one, who's about almost 2.5, my oldest one is not very good at sharing. And whenever we go to people's houses or people come over to our house, people grab toys that are hers, toys that are not hers, and she flips out. She wants the toy that the other kid has. And if you have nieces or nephews or maybe little brothers or sisters, you'll understand this. Kids always want what the other kid has. It doesn't even matter what it is. He has it, so I want it. And that's the way, the analogy that I use when adding and subtracting, rational functions, is to find a common denominator. Think about what one has that the other one doesn't. For example, if we look at this denominator and look at this denominator, the one thing that this has that this one doesn't have is that this is a 9 and this is a 3. So I can simply just multiply by 3 over 3. That's not 3. 3 over 3. The right fraction here, the only thing that this one doesn't have that this one has is the extra x. It's x squared and this is x. So we can simply just multiply this side by x over x to get the x squared. And now you have a common denominator. So let's put everything together. 3 times 7 is 21. The common denominator now is 9x squared. Plus 1 times x is, well, x. And over 9x squared, the common denominator. Now that they have common denominators, we can combine them. The denominators will stay the same. And 21 plus x, again, just like all the previous problems, are not like terms. So they can't combine, so we simply just write them separately. 21 plus x. And that's it. There's no multiplication going on that allows me to cancel out any common factors here. All right, let's step it up a notch, just a little bit. This one might be a little bit tricky to see. One of the things that you're going to always want to think about is, before starting, see if maybe any of your parts of your fractions, either the top left, top right, bottom left, or bottom right, see if either of these are maybe factorable. It's very hard sometimes to see that what the common denominator is when you have this piece over here that's actually factorable. X squared minus 4 is a difference of squares, and that's actually x plus, not x plus 4, x plus 2 and x minus 2. Now, it's way easier to see what one has and the other one doesn't. The left one has the x minus 2, but it doesn't have the x plus 2. So it wants the x plus 2 as well. So we multiply by x plus 2 over x plus 2. Now the right one already has both toys. Think of if they were playing with, Woody and Buzz Lightyear. The bottom right has Woody and Buzz Lightyear, but the one on the left only has Woody. So it wants Buzz Lightyear too. But the one on the right already has both toys. So it doesn't need anything additional. So I don't have to multiply the right side by anything over here because it already has the denominator the other one has. So all we have to do is multiply the left by the x plus 2. So we have to keep in mind here that this is going to need to be distributed, this to this. So I get, let me change colors here, x times x is x squared, x times 2 is 2x. The denominator is now the common denominator of x plus 2 and x minus 2. Then you have minus negative 8 over x plus 2 and x minus 2. Common denominator. Alright, let's shift down here. Now I'm going to combine the top. Now once again, the negative 8 doesn't combine with the x squared or the 2x. So they're going to just stay separate, but you do have this double negative here that will make it a positive. So what I end up with is x squared plus 2x plus 8 all over x plus 2 and x minus 2. Now the one thing you will have to check in these situations is see if this is maybe factorable, because maybe if you factor this it might cancel out with one of these denominators. But you can try as hard as you want, but this fraction or this here is not actually factorable. There's nothing that multiplies to be 8 and adds to be 2. Therefore, this problem is done. So we'll try one more. So you can see one more example here. Let's do number 5. Again, this is a similar example where you want to look here and go, wait a minute, that's factorable. It's a difference of squares. So I'm going to do x plus 5 and x minus 5. Now it's real easy to see what the common denominator is. The only thing that I need to fill in is on the left, this one needs the x minus 5 over x minus 5. So now what I have on the top is x times x, change colors here, x times x is x squared, x times negative 5, negative 5x, over the common denominator of x minus 5 and x plus 5, plus negative 50 over x plus 5 and x minus 5. Now we're going to combine these, but keep in mind negative 50 doesn't actually combine with x squared or negative 5x, so it's just going to stay separate. X squared minus 5x minus 50 all over x minus 5 and x plus 5. Again, now we want to look to see if maybe this is factorable, which in this case it is. It is. There is something that multiplies to be negative 50 and adds to be negative 5. That's negative 10 and 5. Negative 10 times 5 is negative 50, and negative 10 and 5 is negative 5. And lo and behold, you get x plus 5 canceling with the x plus 5 on the bottom. Therefore, your answer is just x minus 10 over x minus 5. So that is adding and subtracting. I strongly, because I know this outcome is very hard, it is one of the most missed outcomes the entire semester. It gets hard. It may seem easy as you're following along with me, but when you go on your own, it can be hard. So try the practice in big ideas, or try a couple of these problems here and see if you can do them correctly, and come up to me if you have any questions. Thanks.